look at the whiteboard, one sample t-test. This is used to compare to a specific number. Okay, now, so how do we address null hypothesis and alternative hypothesis? Okay, so compare means one sample t-test. Which variable I want to compare? Variable age. What is the specific number? 30, right? Okay. So click OK. When you see this one, okay, you could see the name of this table, one sample test, test the value, okay, 30. This is the significance, or we usually call that p-value, okay, p-value. This one is very important, okay, take a note. If the p-value is smaller or equal to 0.05, that is significant. Okay. Result. Point what? 0.001, right? So please tell me, according to this number, 0.01, this is significant or not? Significance, right? Okay, significance. So now, if this is significance, which means we reject our null hypothesis, we accept our alternative hypothesis. So what is the alternative hypothesis? The mean score from the variable age is not equal to 30. Hold on a second. You say not equal to 30, but you do not tell me the number is greater than 30 or smaller than 30. So we need to check the mean score. So what is the mean score? 27.71. So how to write the conclusion? The conclusion is, okay, we need to do this in the professional way because we are professional. The conclusion is the way we address that conclusion. So with this one, you could get something. You have this word. Significance. You are running. Okay. So the specific number is 27. Please tell me this test is significant or not. Please say that louder. Significant or not? Hold on a second, check this one. Significant or not? Why? Because the p-value is 0.274. This number is greater than the number 0.05. So, according to the standard, if the p-value is greater than 0.05, then we say not significant. Okay, so now we know that, okay, Professor, the result is not significant. How do we address the conclusion? The means from variable age, what is p-value? Okay. I will ask you this question. So you need to put the p-value there. You could either tell me, okay, the p-value is smaller than 0.05 or the p-value is greater than 0.05. Okay. You could just give me these two, okay, either this one or this one. And this is the way we address, okay, no results. Okay. So you can see we also have some information here. The first one, mean score. Second one, age. Mean score, specific number, percent, or you could say not or not, okay, the same, okay, or is equal to the number 27, okay, and the p-value is greater than 0.05. Difference between males and females on variable WS1. So based on this question, how do we address our null hypothesis? Okay, so Winnie is Winnie here. Winnie. So Winnie, could you tell me, according to this question, how do we address our null hypothesis and alternative hypothesis? Could you speak louder? I cannot hear you. Sorry. Male what? Between what? Between male and female groups. On what? On the means. On the mean of the variable. Just the sentences clearly. Okay, let me know you will miss one. Check the code. 0 and 1. 1 is male, 0 is female. Okay. Compare means independent sample t-test. Grouping variable, that is our gender. So you need to put 1 and 0. So if we put 1 and 2, so and you won't get any result because you put the wrong number. Okay, you need to enter 1 and 0. Okay, 1 represent male, 0 represent the female. Okay. What is the variable? Okay, WS1. Okay, WS1. Okay, so that is series 1. Hold on a second, Professor. We have two significance here. Which one should we read? Okay, independent sample test, t-test. We start from this one. So when we run independent sample t-test, you will see assumption. The assumption is variances are the same. Okay. So that's the reason this is called Levene's test for equality of variances. So we read this number first. If this number is significant, okay, smaller than 0.05, it means this one, this test is the result of this test, okay, violates the assumption. What is the assumption? The assumption is, let's read this one, equal variances assumed. Okay, so it means the assumption is all the variances are equal. This one is violated. So we need to read this one. Let me say this again. If you see this number is significant, you need to read the second row. If you see this number is not significant, you need to read the first row. Okay, so this p-value is to determine which one you want to read. Okay, based on this one, we know that this is significant, so we need to read the second one. Okay, and the computer will automatically adjust the number. Okay, so you can see the degree of freedom. Okay, is changed, but the result doesn't change. But sometimes it's changed, but it won't change a lot. Let's see this one. Read the second row. Please tell me according to the p-value. So what is the number of p-value? 0.053. So we run two decimals. So the number should be 0.05. So according to this one, this test is significant or not? Significant or not?
No.
Significant, right? Okay, because it's just reaching the number 0.05. So if it's significant, how do we adjust the conclusion? Okay. The conclusion is there is a difference, or they are different, between males and females, okay, on the mean score, okay. mean score. Male 2.91. Female, what is the mean score? .115. So this is the conclusion. The mean from the male group. Quotes, put the mean number. Okay, we need to tell other people the mean number. Mean is 2.91. Is not the same. Is greater. Okay, so some of you may use the word. Okay, you may use the word large. The professional word that is called significantly. Okay, let's see that again. The mean from the male group, okay, mean score 2.91 is significantly. Okay, so when I see that, I know you are running a test. Again, we are comparing the mean scores from between males and females. WM4. Okay. Again, 4. What is the result? First, we check the p-value from the test of equality of variances. Please tell me, significant or not? Not. So if the result is not significant, we have to read the first row or the second one. First one, right. First one. So now the first one, p-value. So please tell me p-value, this one is significant or not? Not. Okay, so with that, how do we address the result? The mean from the male group. What is the mean score? The mean score is 4.12. 4.12 is, because that is not significant, so we don't need to put that word. We can put other word. The mean from the, so we finish the second one. Okay, let me finish the third one. 2 represent the scores in January. And July, okay, the variable WS4 represent the scores in July. From a sample, is there a difference between the 2 time points? So if you look at the data sets, C, gender 0, 1. So please tell me subject 1. This one is male or female? This one is male or female? Female. Subject 2. This one is male or female? Male, right? They are different people. Variable WS2 and 4. This one and this one. Okay, so now please tell me subject 7. What is the number for WS2? What is the number for WS4? 4. They are from the same person, subject 7. So we have to select pair t-test because the 2 numbers, they are from the same person. So it's very easy to identify which one you have to select. If you see the numbers they are from the same person, you need to select pair t-test. If you see the numbers are from different people, and then you need to select an independent t-test. Or if I ask you to compare to a specific number, and then you select one simple t-test. Okay, so let's look at this one. The null hypothesis is there is no difference. Okay, difference between what? Between mean scores in January and July on what? On job satisfaction. Okay, on job satisfaction. We need to tell other people the variable. Okay, variable we try to measure, we try to assess that is job satisfaction. And the time point is January versus July. Okay, so that is our null hypothesis. So WS2 and WS4. Compare means. Pair sample t-test. WS2 WS4. Okay. So now we're going to ignore this one. Let's see this one. Pair sample test. So please tell me this one is significant or not. Not significant, right? Okay, why? Because the p-value is greater than 0.05. So how do we address that? Okay, so this one is okay. There, but if we get there is a what? A significant difference.